All right, today we're pulling back the curtain on one of the most powerful network simulators out there, NS3. If you've ever wondered how you could build and test a network without a single piece of physical hardware, you are in exactly the right place. We're going to break down its core concepts by building a really simple network from the ground up, using its main tutorial script, first.cc. Let's get into it.
So, here's the game plan. You see this network on the screen? It's pretty simple. Two computers, or nodes, connected by a single link. One's going to be a server, the other a client. And believe it or not, we're going to build this entire virtual world, step by step, using just a few lines of code. First things first, before any data can fly across the network, we need the hardware itself, right? In the virtual world of NS3, that means creating our computers and the cable that connects them, all inside the script. And here's how we do it. These two little lines of code, think of them as us placing two brand new, totally blank computers onto our virtual workbench. The node container is just a really handy helper that keeps track of our nodes. And nodes.create, too, tells that, yep, we need two of them. So what exactly is a node in NS3? You can think of it as a computer, or maybe a router. But here's the crucial part. Right now, they are just empty shells. They don't have an operating system, no network card, no IP address, nothing. They're just pure potential. Now for the cable that's going to connect them. We use another helper. This one's called the point-to-point helper, to define the physical properties of our virtual link. Here, we're setting the data rate to 5 megabits per second and the delay to 2 milliseconds. Let's break that down real quick. Data rate is simple. It's just the speed of the connection, how fast we can push bits through that virtual wire. Delay is the time it takes for a signal to travel from one end to the other. By setting these, we're actually modeling the behavior of real-world hardware. Okay, so we've got our virtual hardware, two computers, and a cable. Now it's time to install the software, the network brains, really, that will let them actually understand and speak the language of the internet. And just like that, with two simple lines, we've installed the entire Internet Protocol stack onto both of our nodes. The Internet Stack helper does all the heavy lifting for us. Pretty neat, huh? So what is the stack? Honestly, the best analogy is that it's the network operating system for our nodes. It installs all the essential protocols like IPv4 and UDP, giving our empty shells the ability to finally understand IP packets and communicate. Without this, they're just, really expensive virtual paperweights. Now that our nodes can speak IP, they're going to need unique addresses. This block of code sets up a base network address, 10.1.1.0, and then it just automatically assigns a unique IP from that range to each of our nodes. And here's what we get. The IPv4 address helper just works its way down the list. Our first node N0 gets the address 10.1.1.1, and our second node N1 gets 10.1.1.2. And just like that, they are unique, identifiable citizens on our tiny little virtual network. We've got hardware, a network operating system, and addresses. The infrastructure is complete. Now it's time to install the applications that will actually do something and generate some traffic. First, we set up our server. We use a UDP Echo Server helper and tell it to listen on port 9. Then, we install this app on our second node, N1. But hang on, look at those last two lines. We're not just running the server, we are explicitly scheduling it to start at 1 second into the simulation and stop at 10 seconds. This is a super important concept. The server's job is incredibly simple. It just sits on node N1, listens on port 9, and its one and only purpose in its virtual life is to get a packet and immediately send an identical copy right back to whoever sent it. And the start and stop times are crucial. They're scheduled events, a concept we're about to see in action. All right, next up is the client. We configure it to send a packet to the server's address and port. We also set an attribute telling it to send a maximum of just one packet. We install this client on our first node, N0, and schedule it to start at the 2-second mark. So the client's mission is crystal clear. Send one 1024-byte packet to the server at 10.1112 on port 9. But notice we're starting it at second 2. Why is that? Because we scheduled the server to start at second 1. This makes sure that when our client sends its packet, the server is already up, running, and ready to listen. It's all about event synchronization. And that's it. All the pieces are in place. We've built the hardware, installed the protocols, and configured the applications. It's time to flip the switch and bring our virtual network to life. These two commands are the grand finale. Simulator.run kicks off the simulation engine. It looks at all the events we've scheduled, the server starting, the client starting, and just executes them in order. Once everything's done, simulator.destroy cleans everything up, and our simulation is complete. So what happened? Let's trace the packet's journey. At exactly 2 seconds, our client sends the packet out. It travels across our link, arrives at the server, which then echoes it back, and it arrives back at the client just a few milliseconds later. But wait a second. Yeah, look closely at that second line. The server receives the packet and sends it back at the exact same timestamp, 2.00369 seconds. In the real world, that's completely impossible. There's always some processing delay. So what in the world is going on here? And here is the aha moment. NS3 uses something called discrete-event simulation. This means the simulation clock doesn't just tick forward second by second like a real clock. Instead, it jumps from one scheduled event to the very next one. Since the Echo server's job is simply receive, then send, with no program delay, both events happen at the exact same moment in simulation time. So we've built a network, sent a packet, and figured out the secret of simulation time. But why does mastering this one super simple script unlock the entire power of NS3? It's because this script contains the entire NS3 philosophy in a nutshell. It demonstrates everything from discrete event simulation and network layering to the separation of the network's topology from its protocols and applications. Every complex simulation you can imagine, from massive Wi-Fi networks to satellite communications, is built using these exact same fundamental principles. So, the real point is this. You now understand how NS3 thinks. It doesn't see time as a continuous flow, but as a series of scheduled events. By mastering this simple idea of nodes, helpers, and a discrete event clock, you've unlocked the foundation for simulating pretty much any network imaginable. You've just built and run a network in nanoseconds. The only question left is, what will you build next?